Pyrimidine synthesis. Have you ever heard of pyrimidine? Or even wonder what is the components of your DNA and RNA? If not, you're lucky. Because today, you will learn the uses, synthesis, and catabolism of pyrimidine nucleotide. Let's start with the synthesis of pyrimidine. Pyrimidine synthesis happens inside our cell, particularly in the cytosol. Always remember that for us to synthesize pyrimidine, we need three things: aspartate, 5-phosphoribosyl alpha pyrophosphate or PRPP, and carbamoyl phosphate. Step 1 will be the synthesis of carbamoyl phosphate, condensation of glutamine and bicarbonate in the presence of 2 ATP and H2O. This is done by the enzyme carbamoyl phosphate 2, which is the rate-limiting enzyme for pyrimidine synthesis. This enzyme is inhibited by UTP and UDP, but activated by ATP and PRPP. Step 2 will be the synthesis of carbamoyl aspartate. The enzyme used is aspartate carbamoylase or ATCase. In this step, there will be a condensation of carbamoyl phosphate with aspartate with the release of inorganic phosphate. ATCase enzyme is activated by ATP but inhibited by CTP. Step 3 is the closure of the ring to form dihydroorotate by the enzyme dihydroorotase. As you can see, water is released in this step. Step 4 will be the oxidation of dihydroorotate to orotate by the enzyme dihydroorotate dehydrogenase. This step is an irreversible reaction with the formation of the first pyrimidine ring, the orotate. Step 5 will be the acquisition of ribose phosphate moiety by the enzyme orotate phosphoribosyl transferase. This enzyme is also used in the salvage of uracil and cytosine to their corresponding nucleotide. Last step will be the decarboxylation of OMP by the enzyme OMP decarboxylase. There are 5 steps in catabolism of pyrimidines. 1. Conversion of cytosyl to uracil, wherein hydrogen from water and ammonia in cytosine will release ammonia forming uracil. 2. Conversion of 5-methylcytosine to thymine, wherein hydrogen from water and NH2 in 5-methylcytosine will release NH2 forming thymine. 3. Carbon dioxide and ammonia will be released as the ring is being cleaved. 4. Beta-amino isobutyrate will be excreted. And lastly, beta-alanine will be formed and it can be excreted and be used to synthesize carnosine and anserine. Function of pyrimidine. The presence of pyrimidine base in thymine, cytosine, and uracil, which are the essential building blocks of nucleic acids, DNA, and RNA, is one of the possible reasons for the widespread therapeutic applications.